The objective of this lesson is to develop situational equations that represent the volume of rectangular prisms. Situational equations are student-constructed equations that represent a specific situation rather than a generalized formula. In previous lessons, students learned how to represent the bottom layer of a rectangular prism by drawing an array representing the number of units found in this layer. This 3 by 4 array would represent the bottom layer of a rectangular prism with an area of 12 square units. The bottom layer is called the base of the rectangular prism. The number of layers needed to fill the rectangular prism is called the height. The number of units in the base layer can be found by multiplying the length of the array by the width of the array. By multiplying these together, the area of the base layer is 12 units. Each layer in the rectangular prism is identical to the base layer. This prism has 4 layers. A situational equation can be written to represent the volume of this prism by using repeated addition. 12 is added together 4 times to represent each layer of the rectangular prism. Another way to write an equation to represent the volume of a rectangular prism is by using multiplication. Since multiplication is a fast way to do repeated addition, the number of units in the base can be multiplied by the number of layers high. The volume of this prism would be 48 units. The equation can be simplified by multiplying the number of units in the area of the base by the number of layers needed to fill the prism. Here is another example. This array has 5 rows and 3 columns. Multiplying the length of the array by the width of the array would equal 15 units in the base layer. The prism is 6 layers high. Adding the units in the base layer together 6 times would be a way to write an equation using repeated addition. A situational multiplication equation can be written by multiplying the length of the array by the width of the array by the number of layers in the prism. The objective for this lesson was to write situational equations that represent the volume of a rectangular prism. We met this objective by drawing an array of the base layer of the prism, then writing a repeated addition or multiplication equation to represent the volume of the rectangular prism.